Today's lesson is on populations and samples. So you should have your guided notes out so that you can fill in the blanks and follow along and do the practice problems with me as I go. All right, first thing, a population is the entire group that is being studied. So when people do studies and surveys and they say something about the population, they're talking about everyone that they're studying. So an example would be all 7th graders in Grosse Pointe. Now a sample, on the other hand, is only part of that population. So an example of a sample would be the 7th graders at Brownell. So it's obviously a part of all the 7th graders in Grosse Pointe, but it's not the whole thing. A random sample is a sample in which each member of the population has a random chance of being chosen. And that's a better representation of a population than a non-random sample. We'll talk about that in a couple minutes. So an example of a random sample is having all of the 7th grade names in the computer and having the computer select every 10th name. Because then we really have no idea who's going to get selected. It's not all the boys or all the girls or all people with brown hair. It's just random. On the other hand, a biased sample is a sample that does not fairly represent a population. So, let me move this for you. For example, all the 7th graders in Grosse Pointe who are enrolled in honors math. Well, you know, it's possible that students enrolled in honors math, that's their favorite subject. So if I was taking a sample to see how many people's favorite subject was math, sampling all people in honors math is probably not the best representation of everyone. Same way as if I took a representation of all people interested in playing football and I surveyed all the boys, I probably wouldn't get a fair sampling. You really need to sample randomly everyone in your population. Okay, so we're going to talk about different ways of sampling and decide if they are fair or not. For example, the first one we have is Maria surveys only the band students she knows personally, and she finds out that 84% of them want blue uniforms. The other option is John writes each band's student's name on a card, and then he draws out those names and asks those students. And he gets a result that 61% wanted blue uniforms. The way Maria did it is not a random sample. It's a biased sample. She's biased by the people she knows. And maybe they've already talked about it and they all think blue would be a great color. But really, she needs to sample the whole population. And if you can't ask every single person and you're going to use a sample of it, then you need to do it randomly, like John did it, where he pulled out each student's name. We didn't have any idea if they were Maria's friends or not, if they were people that already talked about blue or red or black. They're just random. So that's more fair. Okay, another example. Ferdinand surveys every other swimmer on the team. Okay, 72% of them want to practice early. Anna Maria questions the swimmers who are in her biology class, and only 50% of them want to practice early. Well, maybe biology is their first hour, and it's a really tough class, so they don't want to have to come in and practice before school. But that's not really fair because we need to ask the whole team and see what a random sampling of the team would be, because maybe some people have after-school activities, and they want to practice in the morning. So the way Ferdinand did it, where he asked every other member, that's a better survey. It's not biased. Okay. In this example, we're going to talk about why things are biased. So, example A. The mayor surveys 100 supporters at a rally about the most important issues to be addressed by the city council. Well, this might be biased because of the fact that if the people are already at a rally, they must already support the mayor or support the issues that he came to talk about. So if he's surveying those people, they're probably all going to feel similar about the issues. Whereas if he surveyed random people just by picking their addresses that lived in the city, he would get a better feeling for the majority of people and how they would vote on the issues. So that's a biased survey. So if I asked you unbiased or biased for A, you would want to say biased. All right, B. The principal sends out questionnaires to all the students to find out what kind of music students prefer at dances. Well, that sounds pretty fair. He's asking everyone. So you're going to get responses from people that like all different kinds of music. So that is not biased. Okay, let's go on to C. The owner of a record shop surveys only customers over the age of 18 who shop at his store. Well, hopefully you're thinking, why only over the age of 18? I would want to have my feelings heard and my thoughts heard, and I'm under 18. Well, that's exactly why this is biased. Only people that are over 18 are not the only people that shop at the store, and the record owner or the record shop owner should know that people under 18 are buying music too, and he should listen to their thoughts. All right, D, the teacher writes the name of each student on a piece of paper and questions the students whose names are drawn. Well, this is very fair, so not biased, because every single student has their name in there and has the same amount of chance of being drawn. So the teacher's asking randomly. All right, hopefully you're starting to kind of get the hang of this. All right, flip your notes over, and we're going to talk now about how we can take a survey of the sample of a population and apply it to the whole population. All right, so a principal of a school with 1,500 students estimates that about 400 students will attend a band festival on Saturday. A random sample of 25 students showed that 6 of them will attend. Determine whether the principal's estimate is likely to be accurate. All right, so what we need to do is take our sample of 25 students, and knowing that 6 of those 25 students are going to attend, and we need to put in a proportion relating it to the total amount of students in the school. So you can see our proportion down here. Students attending out of the sample over number of students sampled, and that should equal the total students attending out of the total amount of students. So I'm going to move this up here a little bit. Oops. Let's go back there. Let's move this up so we can write underneath it. Okay, so students attending out of the sample. Well, there were 25 students asked, but only 6 of them were going to attend. So 6 over number of students sampled, 25. So that's my numbers from our sample. Now I'm going to relate those to our numbers from the whole population. So we don't know how many total students are going to attend, so that's going to be our X. But we do know that our total amount of students at the school is 1,500. Hopefully this looks kind of familiar to you. We've done a lot of proportions. We're going to cross multiply. So we take 6 times 1,500, and that should be 9,000. And then we take 25 times x, so equals 25x. We divide each side by 25. And we get 360 equals x. So what we've just found is it's our prediction of how many total kids in the school will go to the band concert, or the band festival. Now we look back at the problem, and the principal thought 400 students will go. So I would probably say to the principal, no, I don't think there's going to be quite that many. I think there's only going to be around 360. So I would not agree with the principal's estimate. I think he's a little too high on this. Okay, let's try another one like that. All right, the owner of a large chain restaurant with 1,200 employees estimates that about 250 employees will ask for winter vacation. A random sample of 40 employees showed that 8 of them will ask for the time off. So let's check out the owner's estimate and see how close he is. So we take our surveyed amount and we say that 8 out of 40 are going to ask for vacation. And we want to compare that to find out how many out of 1,200 will ask for vacation. We're going to do our cross multiplication. 8 times 1,200, and we get 9,600. And we do 40 times x, so we get 40x. Divide each side by 40. And we get 240 people will probably ask for winter vacation. So this chain restaurant owner thought about 250. So that's pretty close. Maybe not quite, but if he's expecting 250 and a few less ask for it, that's probably fine. So his estimate, I would say, is very close. Because remember, these aren't exact numbers. We're taking a small part of the population, our sample, and we're applying an answer we got from them to the whole population. So we don't know if it's going to be exact. It's like our best guess. Okay, that's it for the video for today. If you'd like to watch it again, please do so. Feel free to pause it if you need more information. And then you can start on the worksheet for tonight.